Alright guys, Mr. Trutna, we're going to go over Unit 11 Worksheet 2B. You were assigned to do numbers 13 through 16, and going with tradition, I'm just going to do every other problem, so I'll go ahead and do number 13 and number 15. So I might have to go ahead and I might have to switch to another paper because this takes up a little bit of room, and then I'll come back to this right here. Okay, so I'm going to switch over to another piece of paper to give me time or room to do work. So this is number 13. It is y is equal to x squared plus 2x minus 15. And then this worksheet asks us to do 5 different items. So it asks us to write the following equations in vertex form. That was the first thing. Second thing, we need to find the vertex, and we'll get that from vertex form. The third part was we need to find the X-Intercept or intercepts. And then the fourth thing is we're going to find the Y-Intercept. And then the last thing is we're going to graph this equation right here, this function. Okay? All right, so going back over here. So here's how we find the first thing we're going to do is we're going to put this equation in the vertex form, and we're going to use the concept of completing the square. So here's what we do. Write the y equals part, start a parentheses, put the second power part, which we call the a part, inside the parentheses, put the b part, the plus 2x part, inside the parentheses, and then purposefully leave a gap, and then close the parentheses, and then put the minus 15 outside the parentheses. And what we're going to do is we are going to use our strategy to complete the square to make this a trinomial. So essentially we're going to create a new c value, and we're going to put it inside the parentheses, and it's always going to be a plus, so you could go ahead and put in a plus here. And now we're going to use this strategy to complete the square. So we're going to take the b value, which is positive 2. We're going to divide that by 2. We're going to get a result, which is 1, and then whatever that result is, we're going to raise that result to the second power, and whatever that equals, that's going to become our new c value. So 1 to the second power is 1, so inside the parentheses we should have x squared plus 2x plus 1, and then outside the parentheses we need to balance the equation out, so we're going to put a minus 1 outside the parentheses, and essentially what that does is that minus 1 would cancel out the plus 1, which we're really saying in kind of a roundabout way that this entire equation right here that I wrote in the second line is actually equivalent to the equation that we started with. Okay? Alright, so now what we need to do is, we're not in vertex form yet, we're almost there. Now what we need to do is we need to take the trinomial inside the parentheses, which is what we call, which we got by completing the square, and we are going to factor that trinomial. So how do you factor a trinomial when there's no number in the front, with no leading number? Well, what you do is, remember, you make the t-chart. So I'm just going to make the t-chart right here. And I'm going to take whatever the c value is, positive 1, and I'm going to write down all of the unique pairs of numbers that multiply to make positive 1. There's only one. It's 1 times 1. And then these two numbers, positive 1 and positive 1, will be my two factors for this trinomial if they add up to the b value, and you can see that the b value is positive 2, and 1 plus 1 does add up to 2. So I have found my two factors, so that means my equation becomes y equals, and then my first factor is going to be x and then plus 1, and I got that from the first positive 1, and then my second factor is going to be another x plus 1. And then outside the parentheses, I'm just going to simplify. Negative 15 minus 1 is negative 16. And now you can see that I have two sets of x plus 1. So I'm going to rewrite the equation as y equals parentheses x plus 1, close the parentheses, to the second power. That tells me I have two sets of x plus 1s, minus 16. That right there is vertex form. Okay, so in number 13, the very first instruction was write the following equations in vertex form. I just did that. It was y is equal to parentheses x plus 1 squared minus 16. Okay, now That right there allows me to do step number 2, which is to find the vertex. All right, so how do I find the vertex when I have an equation in vertex form? Well, remember that the h value, which is the number inside the parentheses, and the k value, they tell you what the vertex is. So my vertex would be the coordinates. Since my h value inside the parentheses is +1, that means my vertex's x coordinate is -1, and then it's the k value -16. Remember, when we're writing the coordinates of the vertex from vertex form, for the x value, you have to think the opposite of what you see for h. So I see +1, I have to write -1 in the vertex. But the k value, which is -16, stays the same. Okay, so step number 3 is, now we're going to find the x-intercept or x-intercepts. Okay, there might be 1, there might be 2, there'll never be more than 2 x-intercepts, but there actually might be none at all. So here's how we do it. We go back to my equation in vertex form, and this is how we go about finding the x-intercepts, intercept or intercepts. What we're going to do is that we're going to change the y value to 0, and you're just going to rewrite the equation, but instead of y, put a 0. So we have 0 equals parentheses x plus 1 to the second power minus 16. And then we're going to solve this equation right here by isolating the x. So that means that I have to get rid of the minus 16, and I'll go ahead and do that first by doing the opposite math operation, which is adding 16, and I have to do it to both sides of the equation. And after the 16s cancel out, I would get 16 is equal to parentheses x plus 1 to the second power. Then my next step is I'm going to get rid of that exponent of 2. So I'm going to do the opposite math operation of the exponent of 2, which is taking the square root. And I'm going to take the square root of both sides of the equation. So what that does is that the exponent of 2 would cancel out the square root, and I would be left with x plus 1 is equal to whatever the square root of 16 is. And the square root of 16 is 4, but remember, it's not just positive 4, it's positive and negative 4. Okay? Haven't solved for x yet, but I'm almost there. I now need to subtract 1 from both sides. So I'm going to minus 1 from both sides of the equation. When the 1's cancel out, I'm going to get x is equal to, and I'm going to end up with 2 answers for x. My first answer would be positive 4 minus 1, which is 3. And my second answer would be negative 4 minus 1, which is equal to negative 5. So my 2 answers for x are negative 5, 3, and those 2 answers tell you what the x-intercepts are. So you got to do all of these steps right here in order to find the x-intercepts. Okay, so what are my x-intercepts? Well, they're points, and they would be the points with the coordinates negative 5, comma 0, and then my other x-intercept would be the point positive 3, comma 0. Okay, so there we go. That would be the steps on how to find the x-intercepts. The fourth instructions for this problem was, now we need to find the y-intercept. And notice there's only one, it's singular, so we're going to find the one y-intercept. So here's how we do it. To find the y-intercept, you go back to your original equation that you started with, all the way up here, the y equals x squared plus 2x minus 15. And what you're going to do is, to find the y-intercept, you're going to change every variable x in the equation to the number 0. Okay, so instead of y equals x squared, we're going to have y equals 0 squared. Plus, instead of 2 times x, we're going to have 2 times 0, and then minus 15. And whatever this turns out to equal, that's going to be equal to y, and that's going to be your y-intercept. Well, 0 squared is 0. 2 times 0 is 0, so you can see that we're going to get y is equal to negative 15. So that number is my y-intercept, and we write the y-intercept as an ordered pair. The x value is always going to be 0 for the y-intercept, and whatever this value is that y is equal to, that's going to be your y value. Okay, so that'd be the y-intercept. All right, so, and lastly, we're going to graph. Okay, so as you can see in this problem, you've been supplied kind of like a template for a graph. So what you have to do is you have to fill in the tick marks, and then we're going to use the vertex, the x-intercepts, and the y-intercept to sketch out what my parabola is going to look like when I'm done graphing. Okay, so using just, you can see I'm looking at my x numbers. I have -1, -5, 3, and 0. So I think it's pretty appropriate that I could scale my x-axis by 1s. So that would be like +3 there. And then 1, 2, 3, 4. That'd be -5 right there. That'd be -1. Okay, but then my y-axis, I have to be a little creative. I don't want to use go by 1s, because you can see I have a -16, a 0, a 0, and a -15. So I think what I'm going to do is I'm going to scale my y-axis by make every tick mark worth 5 spaces. So that'd be -20 down here, and I'll go ahead and label my positive values as well. Okay, so you don't have to scale the x-axis and the y-axis by the same amount each time. You could vary it. Okay, so now I'm going to graph it. So to graph it, I'm going to plot the vertex, which is at -1, -16. I'm going to estimate where -16 is. So that'd be 5, 10, 15. So -16 would be a little bit below where -15 is. Let's say about right there. Put a point. Then I'm going to plot the two x-intercepts. So -5, 0 means left 5, up 0, right there on the x-axis. +3, 0 means right 3, up 0, right there on the x-axis too. And that's kind of telling me how wide my graph is going to become. And then the y-intercept is 0, -15, which would be right there. Okay, so then we just connect all the dots. Now when you connect all the points or the dots, connect them in a nice smooth U. Remember, we're making a parabola, and don't stop at the last points. Extend your parabola up a little bit each side, so with arrows to show us that we understand that the parabola keeps going. Not the best graph in the world, but we're showing the major points of the graph as we're doing it. The vertex, the y-intercept, the x-intercepts. There we go. Okay, number 15. Let's go ahead and now take a look at number 15. We're going to do the same idea for number 15 here. So y equals x squared minus 2x plus 15. So I'm going to switch over to my other paper so that I have room to work this out, because the first part that I need to do is I need to change this equation, y equals x to the second power minus 2x plus 5, which, if you recall, this is in standard form. So I'm going to change this into vertex form. So how do I do it? Well, remember, your first step is we're going to keep the y, we're going to keep the equal sign, and then we're going to start a parentheses. Put the x squared part in the parentheses, put the minus 2x part in the parentheses, leave a gap, close the parentheses, put the c value, which is +5, put that outside the parentheses. Now what I'm going to do is I'm going to create a new c value, and remember it's going to be plus here. I'm going to put a new c value right here, and I'm going to use the method called completing the square. So how do I do that? Once again, I take the b value, which is -2. I divide it by 2. I get a result. That's -1. And then whatever that result is, I raise it to the second power. And -1 to the second power is +1. And that becomes my new c value here. Okay, now don't forget this step, because I put a +1 inside the parentheses. I have to put the opposite of that to balance it out, which is a -1 outside the parentheses. Okay, all right, I'm not done yet though, because I haven't got this in vertex form yet. So now I need to take this trinomial, this new trinomial that I created, x squared minus 2x plus 1, and I have to factor the trinomial. All right, now since we've been doing this for a couple of weeks now, you should start being able to see the shortcut, or you should start being able to factor these trinomials just mentally in your head. So what do we know? We know that we're going to get two sets of parentheses when I factor the trinomial. Each parentheses is going to start with the variable x. And then what I'm going to do is to factor it, I'm going to look at the c value, which is positive 1. And then I need to find two numbers that multiply together to make the c value, positive 1, but those same two numbers have to add to make negative 2. And you could see right there, when I divided the b value by 2, that tells me what my two numbers are. That's a shortcut. So my two factors are going to be x minus 1 and x minus 1. And then outside the parentheses, I'm going to simplify this to positive 4. Positive 5 minus 1 is positive 4. So this leaves me with two sets of x minus 1. So I'm going to have x minus 1 to the second power plus 4. And now that equation is my equation in vertex form. So on number 15, my vertex form would be y equals parentheses x minus 1 to the second power plus 4. That now tells me my coordinates of my vertex. Remember the h value, what we call the h value, and the k value in vertex form tell you your coordinates of your vertex. So my vertex is going to be the ordered pair. You take the opposite of what you see for h, so that would be positive 1, and then you take exactly what you see for k. So my vertex would have the coordinates 1 and 4. All right, now the next thing that I'm going to do is I'm now going to find my x-intercept or intercepts. So here's the strategy or the process that you use to find your x-intercept or x-intercepts. You take your vertex form of your equation, which is y equals x minus 1 in parentheses to the second power plus 4, but instead of writing the variable y, change it to the number 0. So you're going to get 0 is equal to x minus 1 to the second power plus 4. And then I'm going to solve this equation out for x. And whatever x turns out to be equal to, that is going to be my x-intercepts. Okay? So how am I going to solve this for x? Well, I'm going to isolate the x. So my first step is I'm going to subtract 4 from both sides of the problem. That would eliminate the plus 4. And that would create a new equation, which would be negative 4 is equal to parentheses x minus 1 to the second power. I have to keep eliminating all the numbers that are on the same side of the equation that the x is on. So my next step is I'm going to eliminate the power of 2. So how do I do that? Well, I do the opposite math operation of the power of 2, which is I take the square root. And I'm going to take the square root of both sides of the equation here. Okay, so what happens when I do that? You will notice that the square root and the 2 cancel out, and then I get x minus 1 is equal to, and now here's the problem, I have the square root of negative 4. Okay, so this becomes a problem because there is no such thing as the square root of negative 4. So you can't, this right here, which I'm circling in green, there's no answer to that. Okay, so what does that tell me? It tells me there's no real answers for x. So x is equal to no real answers. Okay, so there's no answer that I have for x. So what does that mean? Well, remember when I told you about the x-intercept or intercepts, I said there might be 1, there might be 2, there'll never be more than 2, and there might actually be none. There might be no x-intercepts. And if you end up with no real answers, the x-intercepts, this means that there's none. Okay? So what does that mean? It means that what this is telling me is that when I graph this, my graph is not going to go across the x-axis at all. Okay, so it's probably going to be way up here in quadrant 1 and quadrant 2, or maybe just one of the two quadrants, but most likely it's not going to be down here in this graph at all. Okay, all right, but now let's find the y-intercept. So it's going to make it a little bit harder to graph it when I get it done. Okay, so how do I find the y-intercept? So remember, to find the y-intercept, you go back to your original equation in standard form, and you write it down. So you're going to get y is equal to x squared minus 2x plus 5. But to find the y-intercept, what you do is, everywhere you see an x, replace it with a 0. So instead of x squared, we're going to have 0 squared. Instead of minus 2 times x, we're going to have minus 2 times 0, and then we'll have plus 5. And whatever this equals, that's what y is going to equal, and that's your y-intercept. You can see this is equal to positive 5. So that means my y-intercept, and we write our y-intercept as an ordered pair, would be the point 0 for the y-intercept. The x value is always 0, and then 5 right there. Okay? Alright, so now I'm ready to graph. And I'm going to have to get a little bit creative on this graph because I really only have 2 points. I have the vertex, 1, 4, and I have the y-intercept, 0, 5. And remember, if I'm graphing a parabola, you need a minimum of 3 points. But let's go ahead and graph these two and see what happens. First of all, let's scale our axis. So I think I could scale my x-axis by 1s. I think that'd be okay. And then I think I could scale my y-axis by probably 1s as well. That'd be okay as well. 3, 4, 5. Then I'll go ahead and do the negative values as well, although I don't think I'll need them at all. Okay, so I'm going to plot the point over 1 up 4. Should be right there. I'm going to plot the point over 0 up 5, which would be right there. Okay, but I only have 2 points, so I need another point to find out what my y-axis, or what my parabola is going to look like. Well, how do I do that? Well, remember, there's that line, which we called the line of symmetry, which always goes right through the vertex. And since we're graphing a parabola is a mirror on both sides. So if you notice this point, I went over 1, up 1. So on the other side, I could do the same thing. Over 1, up 1. And I could mirror the 0.05 over here, which would actually be the 0.26. Okay, and when I do that, that gives me an idea of what my parabola looks like. So then I connect the 3 points, connect them in a nice smooth U. Do not make a V. Okay, anytime we have a power of 2, we get a U-shaped graph called a parabola. Extend, pass the points, put arrows to show that the parabola goes there. Okay, there we go. All right, use these 2 problems to help you with the even numbered problems if you need to. Okay, talk to you guys later.